Now we can load grids. So there are a few ways, actually several ways of loading grids within RMSP. For now, we're just gonna take a look at regular grids. We also have subgrid data, which we're gonna look at later. So for now, let's stick with regular grids. So the first type of initialization that I would like to demonstrate is the initialization of grids from a scattered of data. So basically the idea here is that I have points in space, it might be drilling data, and that I want to just initialize a grid around that data. So in order to do that, we can do grid equals rmsb.griddata.from and then scat, and then I can press tab, autocomplete, scattered points. That's the function we are looking for. If I look at the arguments here, it takes point data, which is going to inform those scatter locations, and other grid parameters. So we have block sizes in U, V, Z. We have rotation for the grid. We have a search radius. This is how far from the data we want to initialize the blocks. And we are able to specify a buffer. So this is the maximum distance from the bounding box of the point data that we want to initialize blocks for. We can specify the origin for the block model and so on. So let's start doing that. So we have the composites. Composites are point data. And let's say we want to specify a block size of 10 by 5 by 10. And the rotation is going to be 0 degrees. And we want to initialize the block model as far as 100 meters from the scattered data. And that's all that I'm going to specify for now. We can come back to this. So let's take a look at what I get as an output. So here is my grid. As you can see, grids in RMSB are also data frames. And they are also geodata frames, but at the top of it, it is a particular type of geodata frame. It is a grid data. So grid data are data frames that stores information. When we just initialize the grid with this function, we get this column, which is called ingrid. It's all coded to 1. You could remove that column from the start if you slice your data frame, if you don't like to have that column in there. Next, we can take a look at some elements of the grid data. So the grid data is the data frame that holds the data that goes into the grid. But the grid specification is stored in a different object. So every grid data will have attached to it something called grid definition. So in order to access that, we can do grid.gridDef. So this is the grid definition. So if I do a type on this, is a different type of object within RMSB, which is a grid def. We could have initialized the grid as a grid def and then defined a grid data, but I'm just demonstrating the quicker way of doing it. We can use this grid def to generate another grid data. So if I say another grid equals RMSB grid data and say grid def equals grid def, this is, I have a typo, I don't have that yet. So yeah, this is a valid way of initializing a grid data. This grid that I just created is gonna be the exact same as this one in terms of their definitions. So let's take a look at what is the grid def. So if I just print grid def, it tells me the parameterization of this grid. So it tells me how many blocks there are. It tells me the centroid of the first block and the block size in U, V, and Z directions. What I can do now that I generated a grid, I can, of course, visualize that grid. As I mentioned, every spatial object within RMSB has the view 3D function. So I can just do grid.view 3D, and this will create a visualization. Perhaps I want to add more elements to this visualization. So let's just initialize a viewer first, name it viewer, apply a label, and apply the viewer. The reason I'm initializing a viewer is because I also want to add my composites. So label and viewer equals viewer. Missed AE, there we go. So if I run this cell, it's gonna show me the grid and it's gonna show me the composites. I'm not seeing the composites because the grid is covering it, so I can use a alpha equals 0.5, and now I'm able to see the composites. Note that the grid ends at the boundary of the data. So every boundary of the bounding box of the data is bounding also the grid. If I want to extrapolate more the bounding blocks, I can use the arguments U, V, and Z buffer. So let's set U, V, and Z buffer to the same size as my search radius. So I will initialize every block within 100 meters of the composite. So if I run this again, I can now visualize, and as you can see, I extrapolate beyond the bounding box of the data when I'm creating the grid. So this demonstrates one way of creating grids, which is basically based on scattered data. We are now going to move into other types of grid initializations. Another way of initializing grids within RMSP is initializing them from solids. So in order to do that, what we need to do is to use rmsb.gridData.fromSolid. And then here we need to specify the solid that we want to use. In this case, we want to use the low shell. So the low shell is a wireframe that contains the high grade inside. It hasn't been cut by the high grade shell. So we specified the solid, and we can specify the block sizes, rotation, origin, everything. In this case, we just need to specify block size. Let's use the same as before, and a rotation of 0 degrees. And we can name it grid low shell. And we can do a dot head and see the result. So in this case, we are getting the grid initialized inside the grid shell, the low grade shell, but there's nothing inside the grid apart from that in grid column, the same column we got before. So now what we can do is to visualize. So let's create a viewer, and let's add our previous grid. Let's call it grid from scatter, and specify the viewer and give it some alpha. The other thing we can add is our grid low shell. Let's copy this over here and say grid from solid. Let's remove this, and let's also add the actual solid. So low shell dot view 3D, and let's copy some of this. Low shell viewer, then let's set it to 1 for now. Let's see how it looks like. So if I run this cell, it creates a viewer. I do have a typo here. There we go. And this generates the visualization. So The blue is the grid we created before, which is just a buffer from the composite data. And the yellow block, the orange blocks are the blocks initialized using the low grade shell, which is the green wireframe that we are seeing. So that's how you would initialize a block model using a solid. The next way of loading a block data within RMSB that I would like to demonstrate is loading them from a CSV file. This can be useful if you're importing a block model that was generated within different software. So you save your CSV with block centroids with all the coordinates, and then you can load it into RMSB. So let's start the process. Because this is a CSV, we are going to be using the pandas read CSV, and we're going to use some of the files in our data folder, which in this case is this regular blocks.csv. If I do a grid CSV equals that, I can already take a look at what's inside. So basically what we have are coordinates x, y, and z, which are the block centroids. So now what we can do is convert that to a point data by specifying the metadata, which is x, y, and z. So this will make this object a point data. However, that's not exactly what I want at the moment. So let's give one more layer here, which is rmsb.grid data. And the function I want to use here is called from centroids. So this function is, if I'm inspecting inside, it takes a point data as the first argument. That's why I have this entire process here, which is to load the CSV and convert to a point data so that this part will be the point data. So if I put a comma here and take a look at the other things I need to specify, I know, because I created the CSV file, that the block sizes for this CSV file is 10 by 5 by 5. And I also know that there is no rotation in here. So this should be enough to create the grid data. So I'm going to format this cell and run. Note that because grid data is also a geodata frame, I have the check value range that I could run, but because this grid is empty, there's no data inside it, there's nothing to show. But if you are importing a populated grid with columns for, say, domains and variables, this would be useful for you to check that content. And now what I can do is visualize the grid. So let's actually go above and copy some code that we can reuse. Let's copy this one and paste in here and say grid CSV and grid CSV, and the rest is the same. So let's take a look. So this is the grid from our CSV file. As you can see, it doesn't cover all the data locations. It's just a different grid that I loaded from the CSV file.